This is a general form of a double replacement or double displacement reaction. We have two ionic compounds. In black, I've shown your cations, which are always written first. And in blue, I've shown your anions, your negative ions, which are always written second. So what happens is that the cation from the first compound will take the anion from the second, or the cations switch places. So A would be paired with D, the cation from the first compound with the anion from the second, and then we would have the cation being written first from the second compound with the anion from the second. And also we'll learn later that this reaction only occurs if one of the possible products is a precipitate or gas or water in the event of a neutralization reaction. Here we have sodium chloride and silver nitrate reacting in a double replacement, a typical precipitate formation reaction. So I've shown the cations in black and the anions in blue. When we have a double displacement reaction, the anions and cations switch partners. So here on the reactant side, sodium is with chloride and silver is with nitrate. Cation, anion, cation, anion. When I write the new possible products, we're going to pair the sodium, the cation from the first compound, with the nitrate, the anion from the second compound. So we will have Na pairing with NO3. Now we need to check the charges and write the correct formula. In this example, all of the anions and cations are one positive, one negative, so it's a fairly straightforward example, and we'll do something in a moment that's not quite as straightforward. For the second possible product, we'll pair the cation from the second compound with the anion from the first. Remember, always write your cation first. So Ag will go with Cl. And that's a solid, our precipitate, and the reason that the reaction happens. But we'll do more on predicting whether reactions occur later. You can see the reaction is balanced. All the coefficients are 1, all the charges are 1 positive, 1 negative. In the next example, we'll do something that's not quite as straightforward. In this possible double replacement reaction, the stoichiometry is not going to be quite as simple because here the anions and cations don't all have a 1 positive, 1 negative charge. So the first thing is that we still pair the cation from the first compound with the anion from the second, and the cation from the second compound with the anion from the first. So lithium will pair with chloride, but this time the lithium is a 1 positive, the chloride is a 1 negative, so the correct formula will be LiCl. And when we check the solubility rules, we find that that is aqueous, so no precipitate yet. Then we're going to pair the cation from the second compound, the barium, with the anion from the first compound, the sulfate. And there's our solid. When we check our solubility rules, we find our solid. So we look at the equation, and we do need a 2 in front. We need a coefficient of 2 in front of the LiCl, and then the equation will be balanced. So this one, the only difference was we needed to pay attention to the charges and to balance the equation at the end.